We're supposed to choose the graph of the function that has a domain from 0 to 5. That just means the function only exists between x equals 0 and x equals 5, because that's what a domain is. From x equals 0 to x equals 5, this one's fine. X equals 0 to x equals 5, it doesn't go past those limits. So all these look good with that condition. The limit as x approaches 1 from the right and the limit as x approaches 1 from the left are the same thing. So here's x equals 1. The limit as x approaches 1 from the right is coming from this direction. So as we get closer to x equals 1 on the coming from the right, as we get closer to x equals 1 coming from the left, we're getting the same y value. It looks to be like y equals 1.5. Now we never actually reach it, but we can get infinitely close because of that open circle. So this criteria holds for this graph. Let's check the next graph. The limit as x approaches 1 from the right is about 1.5. It's the same coming from the left. So it also holds for this graph. Can't eliminate anything yet. Limit as x approaches 1 from the left, limit as x approaches 1 from the right, they're both the same. All these are fine. The limit as x gets closer to 1, and the limit as x approaches 1 from the right. That means, what's the y value when x is really, really close to 1, just a little bit to the right? We're getting the same thing if we do the same approach just coming from the left side. So this criteria is met for all of them. We can't eliminate any yet. f of x is left continuous but not continuous at x equals 2, and right continuous but not continuous at x equals 4. So to be not continuous at a certain point, that must mean like if we're tracing that graph with our finger, we have to lift it to get from one place to the other at x equals 2. So at x equals 2, it is not continuous, this graph, because as you approach it from the left, you have to lift your finger and then put it up here. It's a jump discontinuity. As x approaches 2 from the left, the limit exists, but as you try to approach 2 from the right, you can't do it because there's nothing defined here. So this one is also not continuous at x equals 2. And then right continuous and not continuous at x equals 4. This graph is not continuous at x equals 4 because there's no left-hand limit. To be continuous, the definition is that the limit as x approaches some value, could be like 2, as x approaches 2 from the left, has to be the same of the function f(x). It has to be the same as the limit as x approaches a from the right of f of x, and then those both have to be equal to this value, f of a. Okay, if any of those two don't equal the other, if any of those three things don't equal the other items, then it's not continuous. So look, at x equals 4, there's no limit as x approaches 2 from the left because there's no function defined here. So it is not continuous at x equals 4. It is not continuous at x equals 2. Neither one of these, I think, can be eliminated. This one's discontinuous at x equals 2. Sorry. X equals 2, it's discontinuous. X equals 4, discontinuous. So we still can't eliminate anything here. This one is discontinuous at x equals 2, discontinuous at x equals 4. Discontinuous. We still haven't eliminated anything. So all three of these have been met. Okay, this is probably where we'll be able to eliminate them. fx is a removable discontinuity at x equals 1. That's what happens when you have an open circle and then a dot right on top of it. This has a removable discontinuity. X equals 1, removable discontinuity. X equals 1, removable x equals 1. These all have removable discontinuities at x equals 1. A jump discontinuity at x equals 2. That's where you're tracing with your finger coming from the left, and then you have to lift up your finger to put it back down to go to the next part of the graph. So this has a jump discontinuity at x equals 2. This one does not. Look, at x equals 2, a jump discontinuity would only happen if we had a y value directly above. Okay, so we have finally eliminated one of them. X equals 2, this has a jump discontinuity. Still in. X equals 2, look, you can't jump to the next part of the function, so this does not have a jump discontinuity. Okay, so we eliminated two of them. And then the following limit holds. As x gets closer to 4, coming from the left, you go towards negative infinity, which means you should see on your graph at x equals 4 something that looks like this. You're plummeting. You never quite reach 4. You keep going down towards negative infinity. Okay, so let's check the first graph for that limit to see if that exists. As x approaches 4 from the left, that's using this part of the function. We're getting closer and closer to 4 from the left, but we're approaching positive infinity, so this is eliminated. This is our only remaining option. Uh-oh. I missed something. Sorry, this one's non-eliminated. I didn't scroll down all the way. Look. Maybe you saw this and you watched me make the video and you're like, what are you doing? Okay, we got to go back. I didn't see this part of the function down here. Like down here, we removed this because of x equals 2. As x approaches 2, we do have a jump discontinuity. We have to jump down. I didn't see that part. So this is not eliminated. This is the only one that we eliminated. And then we just eliminated this one because as x approaches 4 from the left, we go towards positive, not negative infinity. As x approaches 4 from the left, this one also goes to positive infinity, so this one has to be removed. That's what caught my eye and made me realize I must have missed something on a graph because I eliminated everything. And this last condition is limit as x approaches 4 coming from the right. So here's x equals 4. Coming from the right means we're using this part of the function. As x gets close to the 4, we get infinitely close to the y value of 4. And so that checks out. So there, by process elimination, this is the right answer.